All right, we're back. We're on page 115 of the math analysis notes, and we just talked about the law of cosines, right? Which is side, 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 side angle, side, one of those. Side angle, side, we found already is related to an area formula, right? The side angle, side area formula, which is 1/2 AB sine C is one way of thinking of it, but really it's 1/2 side, side, sine of the angle between them. So it's side angle, side. And now there's another formula, which is really like a side, side, side formula. We're not going to prove it. I used to think the proof for this was like impossibly hard, and then I like looked it up recently, and it looked way easier. I don't know if like I just was intimidated the first couple hundred times I saw the proof, or if I like somehow accidentally found like a different proof. Maybe, I don't know. But anyway, we don't prove this. We're just going to use it. If you want to see a proof, hit up Google, I'm sure, or DuckDuckGo, or whatever your search of choice is, and you will find lots of proofs of this. So we're just going to use it. So it's Heron's formula. It's often, you'll see Hero's formula, like no N. I don't know why. I guess there's some discrepancy in the name. I always think Heron, you know, I confuse Heron with Herod, who is definitely a guy in the Bible, I think. I don't really know. I'm not really good with the Bible. I think there's like a King Herod in there, possibly. But anyway, not the same guy, I think, or maybe it is. But this is Heron, like the bird. Maybe it's named after birds. I don't even know. I should be a little better at the history of this stuff. But anyway, here's what we got. If we know all three sides of a triangle, so we know side, 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 we're going to calculate S, the semi-perimeter, which means half of the perimeter. So S is just the perimeter, which would be A plus B plus C, divided by 2. This is mind-boggling that anyone ever worked this out, never mind like some ancient person. The area of a triangle is given by, if you know all three sides, and you've calculated S, the semi-perimeter, the square root of S times S minus A times S minus B times S minus C. What? Isn't that insane? That's definitely insane. Let's see if we can use it. So first, so this is a 3, 4, 5 right triangle. 3, 4, 5 right triangle means we could find the area by hand. So it's 1/2 of 12, so it's 6. What's good about that is that it gives us a baseline to see if we're like out of our minds when we do this. So let's try to do this one by hand. So S is going to be, I got to add them up. So 3 plus 4 plus 5 divided by 2. So that's going to be 12, so 6. And then the area should be A. I guess I should write area because A would be like the angle in this context. Area is going to be the square root of 6 times 6 minus 3, 6 minus 4, 6 minus 5. You can already see this is going to be right. Right, the square root of 6 times 3 times 2 times 1, which is the square root of 36, which is 6. Is your mind blown? I mean, it should be. That's nuts. That we can find the area. So if we know all three sides, this is fantastic because it's like a really straightforward way of doing it. So let's see if we can use a calculator to find the area of this. I'm not doing this by hand. I doubt I'd be able to because at the end you probably get the square root of some crazy decimal. So let's go to the calculator. So let's do this like the hard way, which, you know, poor choice, but whatever. New problem. All right. The hard way would be that I calculate S, which will be a 2.9 plus 3.7 plus 4.5 divided by 2. And now I'm going to type it in. So it's S times S minus 2.9, S minus 3.7, and S minus 4.5. Okay, so I'm thinking that the area is, okay, I'm writing it down. I'm doing the highlighter thing like all day. Tried to write that in highlighter. So I'm gonna say the area is approximately 5.345. Now think about this. You now know multiple ways of finding the area of a triangle. So a really good way of checking your triangles is to find the area 2 different ways and see if you get the same thing. If you get, well, you're gonna get, because of rounding, it's gonna be like close but not exact. But if they're really clearly different, like you know that you did something wrong. Let's see if we can speed this up. So let me first delete that variable. So I'm going to delete the variable S, so del var S. And now if I press S, there's nothing there. All right, let's call it Heron's and we'll feed it A, B, and C. All right, so it's going to be, I'm going to use S here. It feels weird to do that, so it's the square root of, so S times the quantity S minus A times S minus B times S minus C. So this multiplication here at the beginning, that's not optional. You need that, or it's going to say invalid implied multiplication, which means you invalidly tried to imply that you're multiplying, I guess. It basically means you have a variable and then open parentheses, but there's no function named that. It thinks you're naming a function S that takes an argument of whatever's after it. So like that's where you get that error. I need to tell this thing what S is. I'm going to feed it A, B, and C, but it doesn't know what S is. I'm going to do such that. So such that is control equals, and then just go 1 to the left, such that S equals, and then a fraction, A plus B plus C divided by 2. All right, so I should be able to do Herons of 2.9, 3.7, 4.5. And I get 5.345. Again, same answer. I can now do Herons of like anything but 3, 4, 5, and you get that. So it works. This is the kind of, you want to know how to do this. Like you want to be this level of proficient with your calculator because it just makes your life so much easier. Like I can't tell you how many ways I use the calculator where people are like, oh, but you know, it's like cheating. It's not cheating. I know what I'm doing. Like know what you're doing. And then if you're allowed to use a calculator, you know, good for you. Trying to get back to the, here we go. All right. So got some screenshots for you of how I use the calculator. Now the calculator, if you're on the calculator and you just say Heron of ABC, it'll spit out a formula. This is the formula that it spits out. So this, I don't know if you learned anything from this. Maybe if you expand this, there's something a little clearer going on. I don't really know. You got an A to the 4th there, so that's great. And then a lot of other, I don't know. So that's just what happens if you don't feed it values. We just do Heron of ABC. I was curious, like what does this look like expanded? So there's no S because it replaces S with A plus B plus C divided by 2. And then that happened. Anyway, let's see what this one. Use Heron's formula and a graph to find all possible values of C. The third side when A and B are given. So we know A and B, A is 12 and B is 17. Okay. So what does a graph show? Okay, so let's go back to the calculator and see what we're doing. So I already have Heron's formula built in. Like I defined it. So Heron, if I do X, Y, Z, it'll just spit it out like that. Let me expand this. I don't know, no. You know, I really want to know what it is. I'm going to get the numerator. I'm going to square the numerator. I'm going to expand the numerator. You don't need to really do any of this. So we got fourth, everything shows up to the 4th with a minus. Everything shows up like pairs and squareds. And then there's 2 of them. That's interesting. That's like inside the radical, but whatever. That's not what we're doing here. What we're doing here is we're going to use graph. So you want to stay in the same problem, so Heron's formula is still defined. So I can just press var, and Heron's is there. Heron's formula, so I'm going to say it's 12, 17, x. Right, so side A is 12, side B is 17, side C is just x. I don't know what it is. I'm going to press enter, and it's going to graph all the possible areas that you can get, given the sides 12, 17, and like a variable third side. And do I want a slider? I'm going to say cancel, because I don't need that slider. Basically, that always just means there's like a lurking variable somewhere. I need to change the window, so I'm just going to zoom out, because I don't know what's going on. So zoom out. So you can see something weird is happening. Like why? The side of a triangle, these triangles can't have negative sides. So like that, I'm going to just discard right away. Let's zoom box this thing. So here to here. Okay. So this is graphing Heron's formula. The result of Heron's formula is the area of the triangle, right? So this is all possible areas. Now what's interesting, I think, is if I find these x-intercepts, they should be the smallest possible x value and the largest possible x value. So let me do that. Let's do, I'm going to add a graph. I'm going to add a graph of 0. I'll do menu 8, 1, 814, sorry, intersection points. It's menu 813 on the old version of the Inspire. So this is telling me if the side is 5, the area will be 0, which means you don't have a triangle. If the side is 29, the area will be 0, which means you don't have a triangle. Anything between 5 and 29, though, works. So what I'm going to do is I'm going to switch over to the notes and kind of like show this, I guess. Do we have to? It seems like it should ask you for the largest possible, but it doesn't, so that's okay. So let me switch back over to the notes. And then this is actually the last thing we're going to do. The next page is pretty terrible. It's just like, here, look, it's all practice problems. There's more rows than there are problems because some of the triangles have 2 solutions. So these are all practice. You should do all of these, all of them. But anyway, here, I'm going to sketch what I saw. So I saw basically X, and then let's say it's Y. So it's 5, 29, and it looks kind of like this. So this is area of the triangle, and this is the third side. So that's what we get. So I'm going to say that C, I guess, 5 to 29. So now, what is 5 and 29? 5, this is the triangle inequality part. 5 is 17 minus 12, right? So the difference, the third side needs to be bigger than the difference between the other 2 sides. Because if it's not bigger than the difference, it's not big enough to make a triangle. It's got to be bigger than the difference, and then it's got to be smaller than the sum. This is 12 plus 17. So when I was like, the triangle inequality made a lot more sense to me when I used Heron's formula for this type of problem. I was like, oh my God, like now I get why it needs to be bigger than the difference and less than the sum. Like, and it was clear because another context gave me those answers. But so it's confirming the triangle inequality for me. All right, so that's page 115. I'm not coming back to do page 116, no way. I'll put in the description of this a link to an online calculator where you can check your answers. I think the best thing to do, though, is work with a friend or a couple friends or whatever and just compare your answers and see what everyone's doing and compare work. But anyway, work on these on your own. I don't know if we'll talk about them or not talk about them, whatever. But anyway, I'll see you in the next video for a new set of notes because we are not coming back to do these. So I will see you there.